Hi, I'm Casey Dreier. I'm the Chief of Space Policy at the Planetary Society, which is an independent, nonprofit organization dedicated to space science and exploration. One of the areas of my expertise is looking at budgets, particularly historical budgets within the United States. And I'm very excited today to share with you the analysis of the history and hopefully future funding for Mars exploration in the United States, green for the red planet. I'm sorry I cannot be there with you in person. I am unable to make the timing work, but I want to thank the organizers of this conference for allowing me to submit this pre recorded talk. If you have any questions about any of the things you see or would like to follow up, please reach out to me, casey@planetary.org. I'm very easy to find online. So we will get to it because we have a lot to get through today. First thing I'd like to mention, just in context, as I think this crisis of Mars sample return that we're in terms of programmatic and funding capability behind it, but also this really important turning point that we're in, and I'll talk about some of these eras later, of Mars exploration in general. The first mention of Mars sample return in an official NASA budget request is from fiscal year 1978, where they ask for $10 million for some early technical studies for a Mars sample return mission as early as 1988. This is right on the heels of Viking. Obviously, this did not happen. And in fact, fortunes for Mars became very dour afterwards. But Mars sample return has been this lodestar for Mars exploration basically for the last half a century. And the future, whether or not it does happen, and I certainly hope it does, is going to just be profoundly different in terms of how we think about, plan for, and discuss this narrative of ongoing campaign of exploration at Mars. So just something to keep in mind. Some highlights. So all of these numbers are going to be published from NASA to congressional reporting back through the entire history of NASA's funding. I've collated these in a planetary science budget data set that is available for free online. Anyone's available and welcome to use them. These are some highlights, and I should say all numbers are adjusted to inflation to 2023 levels, the last full year that we have data for. NASA in its entire history has spent $36 billion on Mars exploration. That's all robotic missions, all science funding, all research funding, management and overhead that has clear breakouts associated with Mars. More than half of that has been spent in the last 25 years, and that's kind of reflects the era that we're coming out of right now. This is a lot of money. But in the context of how NASA has spent overall, which is 1.9 trillion in the same period, this represents about 2%, 1.9% of all NASA spending. So it's actually a relatively good deal considering the extraordinary discoveries and capabilities that we've developed to explore this planet. The peak funding year for Mars, robotic Mars program, is actually not in the 21st century. It was in 1974 during the peak funding needs for Viking. Viking remains the most expensive planetary science mission ever undertaken by NASA at roughly $8 billion in today's money. The lowest funding year for Mars in its history was only 10 years later at 9.7 million. And really just a small amount of money for ongoing Viking data analysis and study is very, very low. However, since the 2001, since the start of the 21st century, average annual expenditures for robotic Mars program have been closer to $800 million a year. So a pretty extraordinary turnaround and something, again, to keep in mind as we go forward. Very quickly, I just want to put this in context. Here's NASA's spending over its entire history, adjusted for inflation. Just focus on the green line for right now. On the left is Apollo. You see the big drop off after Apollo, and then it's kind of a peak in the middle around the shuttle and International Space Station era. But since this turn of the century, pretty consistently flat with some ups and downs, around 25 billion a year, adjusted for inflation. We have had an extraordinary 10-year run where we've been getting more and more budget every single year. That has ended. And not just with inflation ending it, which has made NASA's buying power less, but also Congress itself and the White House both providing and requesting less and less money for NASA. So we're on a downward trend right now, which is not a great place to be for doing all of these missions. Because as you know, the more you spend on science, the more science you get. There's no real shortcutting that. Just for some context too, within NASA, that's Planetary Science Division, or in this case, kind of all solar system exploration funding, This is its entire history. This is the era of Apollo here on the left. You see the Viking era, the spike, second spike from the left, the very near death of planetary exploration in the early 1980s and its slow crawl back. You have this, of course, big cuts in the early 2010s, followed by some really extraordinary investments happening in the last 10 years that have enabled not just Mars program, but this expansive program of outer planets, small bodies, and other destinations. That has changed in the last couple of years. We are seeing cuts primarily directed at Mars sample return. But again, just broadly still, we are in a historically high level of funding from planetary science. Though again, we'll see how big this peak is. Here's the key graph that we're going to talk about today. This is funding for Mars, this red line, actual expenditures. The dotted green line is just as it is a percentage of all solar system expenditures that we've seen before. And this little line down here is as a percentage of NASA funding. You can see again that just the dramatic expenditures on Viking and also how short-lived it was. It did not last. And this may be a valuable piece of reference for thinking about MSR, which will be a comparably expensive ultra flagship class mission. Can we contain or control that spending after its success? We have this, I guess we might as well bring this up. We have a variety of eras that we can think about. Just looking at this funding chart, obviously debatable, but I think initial kind of helpful thinking about the eras of past Mars exploration. Initial sorties with Viking and Mariners. They started the better, faster, cheaper era in the 90s, where Mars really began to pick up steam with Pathfinder and then the Mars Surveyor program. And then I'd probably the golden era of Mars exploration, follow the water, where we had lots of sustained investment, launching every Mars launch opportunity, and also really emplacing the infrastructure that we have still today at Mars. And I would argue after the landing of Curiosity and the selection of Mars 2020, that we've entered the Mars sample return era that is still undetermined. This dotted line here going forward, we will talk about that soon, but this is the current budget request from the White House for the next 5 years for Mars, both Mars sample return and the extant Mars exploration program. And notice, just in context, this is the lowest amount of spending since the late 1990s at this level. So basically in almost 30 years. Something else for context, this is the percentage of expenditures for planetary science based on destination. Light gray is the moon. Red is Mars, of course. Yellow is Venus. Blue is outer planets. Small bodies here in this kind of mauve, and then a little bit of Mercury up here. You will see, follow the water era in the early part of the 21st century, occupied more than half of all spending, closer really to 2/3 of spending from planetary science was spent on Mars. That percentage has been dropping as we have done both, there are fewer Mars missions, less spent on Mars, but also more destinations being serviced. These increases here this is start of the Artemis CLIPS related programs, more missions to small bodies, and then ongoing missions to outer planets. So going back to this broad look at historical aspect of Mars, let's focus in on the last 15 years, because I think that's, in terms of political context, really what people are keeping in their heads. This is a helpful historical context, again, adjusted for inflation, that Mars funding, this is again, both Mars exploration program and MSR, been bouncing between $500 million and $1 billion per year. This projection from the White House is very bad. This basically makes it impossible to do Mars sample return, and we don't know what the future of Mars sample return obviously is going to be, but this is their current request at about $200 to $100 million a year. This includes no new missions for Mars exploration, though it does include a little wedge of funding at the very tail end here for what's called future exploration, a potential future mission, but not much. If you were to do Mars sample return at a revised $6 to $6.5 billion level, with anything approaching kind of a classic development curve, cost curve, your funding needs look something like this going forward, this dotted green line. And again, we don't know what these numbers are actually going to be. This is purely based on historical averages and don't have any particular insight, and obviously we don't even know what the structure is going to be, but just say we need to spend $6 billion in 10 years on Mars sample return. You will see some pretty significant increases necessary by the end of the decade, maintaining, again, your current level of investment of Mars exploration. So this has no new real starts. it only has MSR and running out every existing mission. If you want to start new missions, then your budget line starts to look something a little more like this. Obviously, a lot of assumptions built into here, but this is, we're talking about potential commercial partnerships. What I did here for discussion's sake is take the amount that NASA has been spending on the commercial lunar payload services per year, which is about 250 to 300 million a year since its start in 2019. And then added on also a bit of extra NASA spends on top of that, another 75-ish million per year developing instrumentation to ride on these payloads things, right? So even though it's a commercial program, it doesn't mean it's free. So NASA has spent over $1.5 billion since the start of CLIPS, and we just saw the first landing attempts this year, 5 years into the program. Again, so if you want to see something in approaching any type of commercial partnership with Mars, launching in the early 2030s, you got to start funding that next year, maybe 26. And on top of MSR and on top of your extant missions, you are really approaching some historically high levels of funding, not just obviously here in the last 15 years, but ever, and particularly for ongoing commitments, right? You need funding at a regular amount at high level for a very long time. In addition, of course, as many of you know, the cost of doing business has been going up. This plot just kind of is a way to visualize that. This is a missions plotted by their launch date. The y-axis is the number of days based in development since start of formulation to launch. And then the relative area of each dot is the cost of the mission. Now we have, just for, again, consideration here, MSR would fall into it something like this. And either this is the idealistic $6 billion launching in the early 2030s, or the IRB response MSR of $11 billion launching in 26. Very different trajectory. And there would be no other Mars missions probably in this period, with the exception of maybe something in the early 2030s if fortunes change. So takeaways, there is increased competition for NASA dollars right now, both within planetary science with all the destinations we're serving, missions like Dragonfly, commitments like planetary defense that just did not exist 15 years ago, and outside planetary science division. Obviously, NASA's pursuing Artemis to return humans to the moon. That is not cheap. In order to pursue MSR and start in situ science again, which again, Perseverance is the last in situ science project on the books. Even commercial contributions will cost money, and that money tacked onto running our current missions and pursuing MSR at pretty much any expected level will require historically high levels of funding for robotic Mars exploration that is sustained over time. This will come at a point of extraordinary pressure on NASA's science program, which is being cut right now by Congress, and also NASA itself, which is being kept flat during some very high-level political pressure to restrict spending on U.S. Federal programs. Mars missions themselves have become more infrequent and more expensive. However, and this is the positive thing, budgets can change very fast, for good or bad. We've seen that on the chart. And I think we have an opportunity and maybe a lesson looking at the future of the period that we had the most stability and the most funding for Mars exploration was a period where the narrative was very clear about why NASA needed to pursue a campaign of ongoing exploration at Mars with lots of medium to small size missions and a large mission or two in there. Once we go to large missions, very large missions can create a situation where you can have dramatic fall off after they succeed. And so Viking history of that, I think, plays into this. So thinking about how to, whatever future the community chooses and elects to pursue, will have to fit within this context somehow. And again, historically, that suggests that having this clear umbrella narrative for an ongoing campaign has been very valuable. So I'd like to again thank everybody for listening to the talk today. You can find me on our website at Planetary Society. Email me at Casey@planetary.org. Thank you, and I look forward to hearing more about this discussion.